Let's see if this is better this time. Looks better already. Forgive me if you can hear my chewing. Hmm. Mm-hmm. So the naive approach is to do the double pass. How can we cache some values? I always has to be greater than j, yeah, or less than j. So, hmm. So this would be O of n squared. It's a bit slow though. I wonder how we can optimize. Maybe this is it. I don't know. Yeah, too slow. Maybe something like well, oh, it's probably this. Nope. It's interesting. Oh, maybe something like Hmm. Wait. I'm definitely processing this wrong. Output values I. Hmm. I don't think this will work. Dang. output values I. Hmm. Hmm. I'm like kind of ashamed that I haven't gotten this. I think this may be flawed, but Interesting. Interesting. Watch it be super simple. Oh my god, can I make program? Hell no. Are these really recursive? Like, wait, actually no. I guess DP technically isn't recursive. I got the first line right. Okay. Will max left always be... What did I do wrong? No way this works. What? Oh. That was one off. Interesting. DP's hard, man. DP is real hard. Okay. Interesting. Does this use, yeah, it does. So we keep track of left. 8, 1. That's 0. So our values are 8. That doesn't cover 5 minus 2, 3. 8 plus 3. So that checks out. That's 11. 8. -1. Nope. 8. Okay. Interesting. Oh, it's plus. There we go. Interesting. Okay. So we're going to iterate through this. We're going to iterate through all the values. And we will find out, we'll determine, or we'll check if there's a 1 or not. If there's a 1, we're going to delete the island. And every time we delete the island, we will initiate a counter for the island. So something like that. We're going to iterate through the grid. And then if the current character in the grid equals 1, then we're going to delete island. And then increment the counter. And then after this, we're going to return the counter. And then we will write the delete island method. So if the current coordinates are out of bounds, so if row is less than 0, call is less than 0, or row is greater than or equal to grid.length, or call is greater than or equal to grid row.length, we're going to return. Otherwise, if the current coordinate equals a 0, we're going to return. So now we know we have a valid spot in the grid and it's a 1. So we're going to take that current coordinate and make it a 0. And then we are going to recursively call this. But we're going to increment the row by 1. We're going to decrement the row by 1. We're going to increment the column by 1. And we're going to decrement the column by 1. And that will be able to allow us to determine the islands. So this occurs in O of n times m, where n is the width, or n is the height, and m is the width. This occurs at most O of n times. So this is a very similar situation, except we are storing the max area. And if we encounter a 1, we're just going to calculate the area instead of deleting. Or we're going to calculate the area and then delete it as well. So we're going to iterate the grid. So if the grid's value equals 1, we're going to set max to the max of itself and calculate island with I and j in grid. And then we return max. For the calculate island method, we're going to take in a row and a column and the grid. So if the row is out of bounds or the column is out of bounds, we're going to return 0. If the grid's current coordinate equals 0, we're going to return 0. And then we are going to return 1 plus, or we're going to make the current coordinate 0, and then we return 1 plus row incremented by 1 plus row decremented by 1 plus column incremented by 1 plus column decremented by 1. And this will occur in O of n times m, where n is the height and m is the width. Okay, to clone graph, we will have to topologically iterate through the graph. Yeah, it's very similar to clone, or it's very similar to copy a list with random pointer. So basically we're going to store a hash map with the existing node and a duplicate new node, and then iterate through all of them, iterate through all their neighbors, append all their neighbors, and then we'll add some checks and to ensure that we're not infinitely visiting every node. So we're going to have a map here with the stores a node and it has another node. We're going to call it map. And we're going to put in the map the node that's passed in, and a new node with its current value. And then we are going to get a queue. And take the queue and offer the current node. So while the queue is empty, we're going to take the current node and we are going to iterate through all its neighbors. If we don't have, if the map does not contain the key, then we're going to put the key into the map. And we are going to take the queue and offer the neighbor. And then we're going to get the current value and take its neighbors and add the new references. Or, yeah. Like so. And then I think we can just return map.get node. No. Yeah, something like that. Nice. I think the time complexity is the depth of the graph. Or not. Oops. I think this is a closed problem. Yeah. I actually don't like this problem at all. So we're just going to run DFS on this. And whenever, or we're going to iterate through the entire thing. And whenever we encounter a 0, we're going to run DFS on this. And every time we run into a value that is smaller than the depth that we have reached that value at, or greater than the depth that we've reached that value at, then we're just going to replace it with that value. So we don't do Python. Yeah, so we'll iterate through the grid. And if the current value equals 0, we're going to calculate, sure. And we're passing in the row, the column, the grid, and the current value. So let me make this integer that main value. So if row is less, if any of the values are out of bounds, we're going to return. If the current value is less than the previous value, we're going to return. Less than or equal to be honest, yeah. Otherwise, we're going to make the current value equal to the previous value plus 1. Actually, we're going to increment the previous value, like so. And then assign it to the current position in the grid, and then calculate the rest by incrementing row by 1, decrementing row by 1, decrement call by 1, and do that. And I think this should take care of it, or not. It made everything small. Oh. It looks like it didn't do anything. What is going on? I'm off by 1, yeah. There we go. Okay, this occurs in I actually don't know the time and space complexity of this. Yeah, it's quite a bit. Oh, it's M times N. Nice. Optimal. Routing oranges. This one's fun. Okay, so this is BFS. We're going to topologically iterate through all of these values. First, we're going to count how many routing oranges we have. And then we're going to store the coordinates. And then we're going to topologically iterate through all of the routing oranges. And then infect their adjacent oranges. And then we'll keep a tracker for the minutes. So we're going to make a queue that stores arrays of integers. And then we're going to iterate through the grid. if the grid currently is rotten, then we're going to offer the queue a new array with the coordinates. Yeah, the coordinates. Otherwise, if it's a fresh orange, we're going to do that. So if fresh oranges, we're going to return 0. If there are no fresh oranges, then it takes 0 minutes to infect any of them. And then while the queue is not empty, we're going to get the coordinates, get the row, get the call, and we're also going to implement some directions. So for each direction in directions, we're going to make a new row, which is going to be equal to row plus direction 0, and a new call, which is going to be equal to call direction 1. And if new row is greater than or equal to 0, and new call is greater than or equal to 0, and new row is less than grid.length, and new call is less than grid new row dot length, and that new value equals a rotten tomato or a fresh tomato. We're going to take the fresh tomato counter, or sorry, fresh oranges counter and decrement it. We're going to take the queue and offer a new integer with those new values. Yeah, that's about it. And then I forget a very important part. Oops. We have to keep track of the minutes. Okay, perfect. So our return, and if rotten oranges equals 0, then we'll send the minutes. Otherwise, we're going to send -1. What's wrong? No. Sorry, fresh oranges. Huh. How is this infinite? I definitely have a mistake somewhere. We're polling. Equals 1, fresh orange. It's absurd to believe that this would be running infinitely, but maybe I'm absurd. Yeah, this makes sense. It's got to be some tiny thing. This all looks right. We're polling every time. Oh. I have to reset I have to set it to rotten. It's min is -1. Wow. I'm actually surprised I caught that. Eight submissions. Oh, I'm tired. manager? What? That's crazy. I can upload at 4K at like very terrible upload speed. That is insane. I didn't realize that. My upload speeds are garbage, but I'm streaming 4K right now.